Alright, so I just got my hands on the 2023 Methods Exam 1. I heard that it was, the questions weren't too hard, but the numbers were pretty difficult to deal with, so we'll see how we go. So starting off with the typical differentiate. So u is equal to x squared minus x, u dash is equal to 2x minus 1, v is equal to e to the x, v dash is e to the x, so dy dx is equal to e to the x times 2x minus 1 minus e to the x, x squared minus x, all over e to the x squared or e to the 2x. And you can leave your answer like that. You could probably take out e to the x as a common factor. And then, yeah, you could probably simplify this. Oh, and simplify. So the question says simplify. All right. So you have 2x minus 1 minus x squared plus x all over e to the 2x. And that is 3x minus 1 minus x squared, minus x squared minus 1, all over e to the x, I believe. Yep, looks about right. Can we factorize that even? No, can't. Alright, so I'll leave it like that. Fine, okay, so u is equal to sine x. U dash is equal to cos x. V is equal to e to the power of 2x. And v dash is 2e to the 2x. So f dash x is equal to e to the 2x cos x plus 2e to the 2x sine x, and sub in pi on 4, we get e to the pi on 2. Cos of pi on 4 is root 2 over 2, or 1 on root 2, so over root 2, plus 2e to the pi on 2. Sine pi on 4 is also root 2 over 2, so I'll just cancel that 2 and write a root 2 there. So that should be fine. Alright, solve this equation. So you can say that this is e to the x squared minus 4e to the x minus 12 is equal to 0. If you factorize, and you've got 4, 3, you probably got 6 and 2 here. And a minus goes there, so e to the x minus 6, e to the x plus 2. That means e to the x is equal to 6, or e to the x is equal to negative 2. That means x is equal to log base e of 6, and this one is rejected. Alright, so they gave this one 3 marks, which I think should have been less, but that's okay. So here we have an asymptote at y is equal to 2. And we have an asymptote at x is equal to 1. And it says label the asymptotes and the axial intercept. So the y-intercept will be 2 plus 3, or 5. And the x-intercept will be 3 over x minus 1 is equal to 2. X minus 1 is equal to 3 over 2. X is equal to 5 on 2. So that's 2.5. And looks like that, and like that. Alright, find the values of x for which f of x is less than or equal to 1. So less than or equal to 1 is over here. So that would just be from 1 all the way till, we need to solve when it's equal to 1. It looks like about 4, but we'll see. So if I just sub in 4, that's 3 on 3, which is 1, and then 2 minus 1 is 1. So yeah, it would be 4. So 1 to 4, and 4 is included because it's less than or equal to. Alrighty. Use two trapeziums of equal width to approximate the area of the curve between the x-axis and the line x is equal to 1. So that's the line x is equal to 1. And x is equal to 3. So we're going to have this trapezium here. And this trapezium here. Now for the first trapezium, I'll just say area is A. First trapezium is 1/2 times f of 1. Or, so 1 plus 1 is 2. Plus f of 2, which is 2 plus 1/2, which is 4 over 2, 5 over 2. Now, then times by the height, which is just 1. And then plus 1/2. F of 2 we said was 5 over 2. And then f of 3 is 3 plus 1/3, which is 10 on 3. And then times by 1. Just double check that. 1/2 times 1. Yeah, that looks about right. And that is 1/2, 4 over 2, that's 9 over 2. Plus 1/2, 15 plus 20 on 6 is equal to 35 on 6. And that is 9 on 4 plus 35 on 12, which is 27 plus 35 on 12, which is 62 on 12, and that simplifies to divide by 2. You get 31 on 6, and I don't think you can simplify that any further. Units squared. Alright. Now, evaluate that integral. So the integral of sine x is equal to negative cos from 0 to pi on 3. And sub in pi on 3, you get 1/2, so negative 1/2 minus minus negative cos of 0 is 1. So this is negative 1, and that would be 1 minus 1/2, or just 1/2. And so otherwise, find the values of k such that the integral from that is equal to that, where k is between negative 3 pi and 2 pi. So then we're just solving k to pi on 2 of cos x dx is equal to 1/2. So integral of cos is sine. So this is sine x from k to pi over 2 is equal to 1/2. And that means we've got 1 minus sine of k is equal to 1/2. Sine of k is equal to 1/2 is what we're solving in the end. And we're solving that from negative 3 pi to 2 pi. So if you just draw a unit circle, we'll go in the negative direction first. So you can go all the way around like that. So we've got solutions in the first two quadrants only. So actually we'll only have these two solutions, and then the bottom two don't count. So that is k is equal to negative pi on 6 and negative 5 pi on 6. And then we can go in the positive direction from 0 to 2 pi. And so that would be, sorry, I made a mistake. Not negative pi on 6 and negative 5 pi on 6. It's these two solutions. So negative 7 pi on 6 and negative 11 pi on 6. And then in the first two quadrants we have pi on 6 and 5 pi on 6. All right. Let p hat be the random variable that represents the sample proportion of households in a given suburb that have solar panels installed. From a sample of randomly selected households in a given suburb, an approximate 95% confidence interval for the proportion of p households. Okay, so that's the confidence interval, and they want you to find p hat. P hat in a confidence interval is just the midpoint. So 0.04 plus 0.16 over 2 is 0.2 divided by 2, or 0.1. Now approximate the confidence interval. So the confidence interval is p hat minus z, and in this case they said use z, times the standard square root of 0.1 times 0.9 over n. And you can just solve that to equal to the lower bound. You don't have to do both of them. I would probably use fractions here. So this is 1/10 minus 2 times the square root of 1/10 times 9/10 is 9 over 100n. And that's equal to 1 on 25. 25. Now, you can say that 2 times the square root of 9 on 100n, which we can simplify to just be 3 on 10 root n. And then that goes to 5. So 3/5, 3 over 5 root n is equal to 1/10 minus 1 on 25. So they have a common denominator of 50. So 5 minus 2 is 3 on 50. 5 minus 2, yeah. So the numerators are equal. So the denominators must be equal. 5 root n is equal to 50. Root n is equal to 10, and that means n is equal to 100. A larger sample of households is selected with a sample size 4 times the original sample. Sample proportion of k households having solar panels installed is found to be the same. So they've just multiplied the sample size by 4. So if you look at the margin of error, you can see what time is that, what factor is that multiplied by. If I have 4 times n, so it's z times p hat 1 minus p hat over 4n in this case, and k times the margin of error is now equal to, it comes out as 1/2 times z times, and this part is the margin of error, so 1/2 times the margin of error. So the factor is 1/2. All right. Here we have f of x is equal to x squared minus 2x. Part of the graph of y is equal to f of x is shown below. State the range of f. So the range is just -1 to infinity. Yeah, don't think it's too complicated. 1 minus, yeah. Now sketch the graph of the inverse function on the axis below. So you can just, it says find the equation of the inverse. So you might as well find the equation of the inverse first. So for inverse swap x and y, x is equal to y squared minus 2y. Now you probably want to complete the square here. So you're going to have y minus 1 all squared. And then you needed to subtract, so this is y minus 2i plus 1, so you just need to subtract 1. So y minus 1 all squared is equal to x plus 1. y minus 1 is equal to the plus and minus square root of x plus 1, y is equal to 1 plus or minus the square root of x plus 1. Now we need to check which, is it the positive or the negative. Now the domain of this is -1 to infinity, but the range of this should be -infinity to 1. So we have to take the negative. So that means f inverse of x is equal to 1 minus the square root of x plus 1. And that's because since the range is -infinity to 1. Now, I think, okay, so this -1 becomes, sorry, 1 -1 becomes -1, 1. This origin stays the same. And you could use this point if you like. So that was -1, 3, so that would be 3, -1. So that will look something like that. And yeah, that looks about right if you reflect it in the line y is equal to x. All right? And don't make that look like an endpoint. Just keep it going. All right? Does it say label? Okay, so it says label any endpoint. So this here is going to be -1, 1. And axial intercept. So that's just going to be the origin. Alrighty. Calculate the area of the region enclosed by the curves of f inverse, and y is equal to -x. So y is equal to -x is this. Just a bit off. Whatever, like just here. So I think that's just that's this area here doubled. So you can say that that's 2 times the integral from 0 to 1 of the line -x minus the f of x. Yeah, and that's because, okay, so this is doubled. It just doesn't look doubled because my graph is a bit off, but it's this part and this part. So here you can say that that's 2 times the integral from 0 to 1 of -x minus, and f of x is x squared minus 2x. Which is 2 times the integral from 0 to 1 of -x minus x squared plus 2x dx. That's 2 times the integral from 0 to 1 of -x squared plus x dx, which is 2 times -x cubed over 3 plus x squared over 2 from 0 to 1. And if you sub in 1, you get -1/3 plus 1/2 minus 0. That's 2 times -1/3. So it should be 1/3. Alrighty. Is this the last question? No, there's still more. Okay. Suppose that queuing time t in minutes at a customer service desk has a probability density function given by that. Show that k is 1 on 64. So that's just, there's a lot of integration here, but the integral from 0 to 4 of, you can take k out, t times, I'll just expand it as well, 16t minus t squared, t cubed actually. That's equal to 1. Now k times if we integrate this, it's 8t squared minus t to the 4 over 4 from 0 to 4 is equal to 1. K times 8 times 16 minus 64 and 4 is 16 is equal to 1. Now you can take this, I wouldn't bother working out 8 times 16. just take 16 as a common factor, and you've got 8 minus 1. I must have made a mistake. So k times integral from 0 to 4, 16t minus t cubed. 16. I should get 4 here. Cubed. To the 4 over 4. 4 to the power of 4 is not 64. This is, what you can say is it's 4 cubed times 4 over 4. That cancels, and it's 4 cubed, which is 64, or 16 times 4. And then you'll have 8 minus 4 is equal to 1. K times, I don't know why we're equals here. And that means 64k is equal to 1. K is equal to 1 on 64. And then find the expected value. So that's just going to be the integral from 0 to 4 of x times that, or t times that. So you can take out the 1 on 64 again, and then you're just going to have 16t squared minus t to the power of 4 here. Yep. And that is 1 on 64 times 16t cubed on 3 minus t to the 5 on 5 from 0 to 4, which is equal to 1 on 64 times by 16 times 4 is 64, and then I'll write times 4 squared, so times 16 over 3. And the reason why I did that is so I can cancel the 64 here. So I'll just write that 64 here. Then minus t to the 5 over 5. So again, I'll keep 64 out. So 4 cubed is 64. And then times by 4 squared is 16. And that gives t to the 5 over 5, and then subtracting 0 is fine. So here, the 1 on 64 cancels, and it's 16 on 3 minus 16 on 5. Common denominator is 15. So 16 times 5 is 80, minus 48 over 5 is 32 on 5, I think. Just double check that. 16 times 5 is 80, on 15. And 15, and can I take a common factor of it? Can I simplify? Don't think so. Yeah, that is quite a fair bit of algebra, but if you just take common factors and stuff like that, you don't have to work out the big numbers. 580 minus 48 is 32. Looks about right. I'll just move on. What is the probability that a person has to queue for more than 2 minutes given that they have already queued for 1 minute? So probability that, what's this variable t? T is greater than 2 given that they have already waited for 1 minute, so t is greater than 1. Because if they're waiting for 1 minute already or more, so greater than 1. So that's the probability. That's just going to be the integral from 1 to 2 of the function. What's the function? F of t over, actually, is it? No, sorry. That is just probability that t is greater than 2 over the probability that t is greater than 1. And that is the integral from 2 to 4 of f of t dt over the integral from 1 to 4 of f of t dt. Now, we've already integrated it. So you're going to have 1 on 64 over 1 on 64, so the k's, and then you're multiplying by the integral from 2 to 4 of the function, which we already said was 8t squared minus t to the 4 over 4. And that's from 2 to 4, and then 8t squared minus t to the 4 on 4 from 1 to 4. That can cancel. And you've got 8 times 16 minus 4 times... So this is the same problem. We've already subbed in 4. And we got... When we subbed in 4... we got 64, I believe, from here, because the 0 didn't count. So that's going to be 64 minus, then you sub in 2, you get 8 times 4, which is 32, minus 2, 4, 8, 16 over 4, which is 4. And that's in brackets, be careful about that. All over, again, we subbed in 4 already, 64, and then minus 1. So that's going to be 8 minus 1/4. That is 64 minus 28 over 64 minus 32, 31 on 4. Now the numerator is 36, and the denominator is 64 times 4 minus 31 on 4. Now this is probably the first time I'm actually working out 64 times 4. 16, 256. So that's 256 minus 31 on 4, which is 36 times 4 over 256 minus 31 is 225. Now that is 36 times 4 is 144. That's 144 on 225. Can we simplify that? It looks like we can. Okay, so you could write this as 12 on 15 all squared, which is 4/5 all squared, which is 16 on 25. There's a lot of integration in that, and that's pretty heavy working out, but that's okay. The shapes of two walking tracks are shown below. Track 1 is described by the function that. Track 2 is defined by that function. Given that f of 0 and g is 12 and g of 1 is 9. So first of all, f of 0 is 12. That means a minus 0 times 0 minus 2 squared is equal to 12. That means a is equal to 12. And then g of 1 is 9. That means 12 plus b is equal to 9. B is equal to -3. So that's okay. How much more of this? Okay, 2 more questions. So verify that f of x and g of x both have a turning point at P. So f dash x is equal to, you don't have to differentiate for this. That's already in turning point form. Actually, it's not. I'll probably just expand it. Is equal to 12 minus x times x minus 2 all squared. Yeah, you probably do want to differentiate it. So f dash x is going to be equal to negative x times the derivative of this, which is 2 times x minus 2 all to the power of 1. Yep. And then minus x minus 2 all squared. If you solve that's equal to 0, you're going to get negative 2x times x minus 2 is equal to x minus 2 all squared. So from here, actually what you can do is take out x minus 2 as a common factor. So x minus 2, and you've got negative 2x minus x minus 2 is equal to 0. So x is equal to 2, or what's this? Negative 2x minus x plus 2. So that is negative x plus 2. Or 2 minus x. Or you can take out a negative and have x minus 2, and this is just negative x minus 2 all squared is equal to 0. So it's at x is equal to 2. And f of 2 is equal to 12 minus 2, just 12, I believe. Because, yeah. So P is equal to 212, and we just want to check that that's also on G. So you can just use the negative b over 2a. So g of x has a turning point at, don't use b because they've already used b. So just say negative 12 over 2 times a, and a in this case is b, 2 times negative 3, which is equal to 2. And g of 2 is equal to 24 minus 3 times 4, which is 12. Therefore, both have turning point at P. Last question. A theme park is planned whose boundaries, there's so much different integration here. Theme park is planned whose boundaries will form the triangle OAB, where O is the origin, A is at K0 and B is at KG of K as shown below. K is between 0 and 4. Find the maximum possible area of the theme park. So a theme park is planned boundaries. O is the origin. A is. So this is K0 and B is at G of K. So K, G of K. So K and then 12K plus BK squared, or minus 3K squared. And so you just want the maximum area of this triangle. So the area, just say A of K is equal to 1/2 times K times the height, which is 12K minus 3K squared. Or you can expand and say 1/2 12K squared minus 3K cubed. A dash of K is equal to 1/2 times 24K minus 9K squared. And solve that's equal to 0. 24K minus 9K squared is equal to 0. take k as a common factor, you've got 24 minus 9k is equal to 0, k is equal to 0, or k is equal to 24 on 9. And it's saying find the maximum area, so you have to sub that back into a of k, which is a bit annoying to sub in, but a of 24 on 9 is equal to 1/2 times 24 on 9, which is 12 on 9, and that simplifies, I believe, to 4/3. And then 12 times 24 on 9 minus 3 times 24 squared on 9 squared. Let's just write 81. Now, again, you can take out 24 as a common factor. But let's just simplify it first. So we'll take out 24 as a common factor. And so you've got 12 on 9, which is again 4/3, minus 3 times, you've got 124 left on 81. And this here cancels with the denominator 27 times. And then that simplifies to be 8 on 9. So all of this is 8 on 9. And that's 8. So that's 32 times by 3. 12 minus 8 is 4 on 9. And that works out to be 128 on 9. And see if 3 goes in. It doesn't go in. So that's that. That's the methods exam. Again, it is a lot of algebra, but if you just simplify things and try not to do things the long way, which is just to expand and multiply everything out, you might find that it's a bit easier, but it's still, I think, very heavy in terms of numbers. So, good luck.